Hello, our today video is about reproducibility in reinforcement learning. My name is Yusuf and I'm going to present this video. Here you see the list of outline. First of all, we say what is reproducibility. We outline the challenge of reproducibility. We talk about reproducing result in reinforcement learning, and then we discuss about how does the choice of network architecture affect performance. We also talk about how can the reward scale affect result. Finally, we discuss how can random seeds drastically alter performance, and finally we present reference. Okay, what is reproducibility? Okay, reproducibility is the process of obtaining the exact result reported with the same experimental setup. I repeat, reproducibility is the process of obtaining the exact result reported with the same experimental setup. We need to distinguish reproducibility from replicability. What is replicability? Replicability is the process of obtaining the same result with a different experimental uh, setup. While in reproducibility, we use the same experimental setup. In replicability, we use a different experimental setup. When we refer to reproducibility, we are discussing the necessity of generating the same study result using identical method. I repeat, we are discussing the necessity of generating the same study result using identical method. Okay, what are the challenge of reproducibility? The first one is computational. Inherent non-determinism cause different results even if you use the same data and code. Okay, if you use the same data and code, inherent non-determinism cause different results. Okay, that is a good point. Environmental difference such as different GPU, CPU, or compiler library also change the result during the computational process. Okay, to solve this issue, you should fix the random number seed while having the same environment. Okay, to address this problem, you should fix the random number seed while having the same environment. Okay, the second challenging is missing data or code. You cannot have the same result with the ML model trained by different data. Okay, you cannot have the same result with the ML model trained by different data. Okay, to solve this issue, you should ensure that the data is complete and exactly the same. Okay. And the third challenge is methodological. Even if you use the same data and computational resource with the same random seed value, if you don't prevent data leakage and use different train test split, you will get different result. Okay, despite of having the same data and computational resource and using the same random seed value, if you don't prevent data leakage and use different train test split, you will get different results. Be sure that you are using the same methodology. Okay, the methodology also should be same. This is very important. Okay, reproducing reinforcement learning. There are plenty of paper on there are plenty of paper on demonstrating the superior performance of the reinforcement learning algorithm. Okay, one paper, deep reinforcement learning that matters, that is our reference for this video, published in 2018, showed that some claim of the outperformance may simply be due to the randomness of the RL algorithm. Okay, the experiment in the paper show even the same RL algorithm with the same hyperparameter, the different random seed can produce drastically different results. Okay, what is telling this paper is telling that if we are use the same reinforcement learning algorithm with the same hyperparameter, but due to difference in random seed, we can have different results. Okay, reproducing deep RL result is seldom straightforward, and the literature report a wide range of results for the same baseline algorithm. Okay, reproducibility can be affected by hyperparameter or effect of random seed or environmental property. I repeat, reproducibility can be affected by hyperparameters or effect of random seed or environmental properties. Okay, how does the choice of network architecture affect performance? It is shown that policy network architecture can significantly impact results in both TRPU and DDPG. In this figure, see that as you can see here, we have different network architecture, and we see different results for them. We see different convergence for them, and we can understand that or network architecture is very critical and can influence our results. As you can see in this figure, for different architecture, we have different results. Activation function also, the choice of activation function has a huge impact on the result. In this figure you see that our algorithm is TRPU and we are using different activation function, and you are observing different result. Okay, for the same experiment, for theta environment, different activation function generating different results. Okay, how can the reward scale affect results? Okay, reward scaling. What is reward scaling? Reward scaling involves simply multiplying the reward generated from an environment by some scalar for training. Okay, we multiply reward generated from environment by some scalar. Okay, their analysis show that the reward scaling can have a large effect, as you can see in this left figure. For different scalar value, this we have different result. Okay, I think it is clear that reward scaling can have a large effect on the result, as is confirmed by this figure. Also, you can see we have two figures here. The left figure is the use layer normalization, and the right figure is not using a layer normalization. And we have also a still different result. We also can observe the impact of the layer normalization on the result. Okay, can random seed drastically alter performance? Of course, yes. I think all of you are agree that random seed can drastically alter the performance. As you can observing in this figure, for TRPO algorithm for different seed, we have a different result. Okay, I think this is clear, and you agree that random seed drastically alter performance as confirmed by this figure. Thank you very much. Our reference is deep reinforcement learning that matters. It's worth the reading paper, and I recommend you to read it. Thank you very much. If you learned something from this video, I appreciate you like and subscribe. Thank you.